Now, next important part of this chapter, which is about derivatives. So, the first question is, what is derivative? You might have used in the physics also. In general, derivative measures what it measures. In general, it measures change in one variable, I'll give you simple example. You'll realize change in one variable with respect to means what? With reference to. There is some concept of relativity here. Derivative measures change in one variable with reference to the other variable. Change in one variable with respect to the other variable is measured by derivative. If there is no change, derivative is 0. If there is no change, there is no change in the variable, then derivative will be 0. Derivative will be 0. Because what derivative in general measures? Change in one variable with respect to the other variable. So whenever there is a question of rate of change, then it's indirectly question of derivative. If you just recall this example, for example, let's take distance as variable s and time as variable t. Now at some time t equals to 0, for example, one object is over here, and at time t equals to 1, you can consider one vehicle over here, and at t equals to 1, the vehicle take this position. Let's call the position A, here position B. And suppose this distance is, let's take 60 kilometer. So how much change takes place? 60 kilometer. In how much time? In 1 hour. So here we can say that change in the distance, we write ds. So change in the distance, initially here distance was 0 kilometer because this was the initial position. After 1 hour, the objects or the vehicle covered the distance 60 kilometer. So change in the distance, which we write ds, variable s, with reference to time, with respect to time. So we write upon dt. So this is read as ds by dt. How much change takes place? Which is nothing but what? 60 kilometer per hour in 1 hour. Per hour means 1 hour. So this is nothing but the speed of the vehicle, right? So this is an example of what? Derivative. Simple example which I've just stated here. This is nothing but what? Change in the distance. D represent change in the distance with reference to time. In 1 hour, in 1 unit time, it is 60 kilometer. So this is known as speed of the vehicle or the velocity of the vehicle, 60 kilometer per hour. That means in every hour, the change in the timing would be 60 kilometers. Change in the distance would be 60 kilometers. Just simple example for your information. So whenever there is a change, there is a concept of derivative. So this is nothing but what? Derivative of s with respect to t. Fine. If I write derivative of y with respect to x, we usually write dy by dx. If I write derivative of y with respect to t, we write dy by dt. If I write derivative of, for example, y with respect to theta, we write dy by d theta. So this is very commonly used symbol here. This is read as dy by dx. Change in y with respect to x. Change in y with respect to t. Change in y with respect to theta. Right? This is read as derivative of y with respect to x. How do we read? Derivative, this measures change in y, remember. It's like this, d by dx of y. This is operator. D by dx is operator. You are measuring change in which variable? Y. With respect to which variable? X. So d by dx of y, which is as good as dy by dx. D by dt, change in variable y with respect to time here, t. Change in y with respect to variable theta. Like these also you can write, remember. These are all standard notations. This is read as dy by dx, dy by dt, dy by d theta. Okay. So with this brief introduction, I've just introduced what is derivative. And here, the method of finding, this procedure of finding derivative is called differentiation. Method of finding derivative is called differentiation. Is called differentiation here. So differentiation is the procedure of finding derivative of a function. Differentiation, it's a procedure or method of finding derivative of a given function. Okay. Now with this information, we write definition of derivative at a point which is based on limits only. So now we write the definition. Definition of what? Derivative of a function. Derivative of a function at a point. Derivative of f at a. We are writing derivative of a function at a, which is one type of the limit only. So we start with a function. Let f be a real valued function. Real valued function. That means codomain is R. Real valued function. Now what we do? Here we are defining derivative at a, remember. So suppose this is a here. Now for fixed number h, we find a plus h, right, for h non-zero, and then we take the difference of these two. So value of the function at a plus h, value of the function at a with the difference. So what is this? This is nothing but the difference of the values of the function. Difference of the values of the function upon difference of the values of the variable. So a plus h minus a. So it is just h. What is this? This is nothing but what is this? This is a plus h minus a. So you are just left with h. I wrote h directly. This is the ratio of difference of the values of the function to the difference of the values of variable h, and then we try to take this difference as small as possible. So we ask for limit h tends to 0 here. So if this limit exists, then it is called, then that limit is called, then it is called derivative of fx, you can write at a. See, what is this ratio? If you notice carefully, this ratio is nothing but what? Change in the values of the variable f, that is the function, upon change in the values of the variable, this one a, remember, because this is nearby a. So whenever this limit exists, then that limit is called derivative of the function at a. And we write here, it is denoted by this symbol. It is denoted by f dash. Dash stands for derivative. At which place? At a. So it is, this is the symbol. So therefore, you can write f dash a equals to limit h tends to 0 f of a plus h minus f of a upon h. That's one. Or you can write like this also. Here, in general, I can write like this also. F dash x equals to limit h tends to 0 f of, now you are finding at x plus h minus fx upon h. Fine. What I did, just I have written x instead of a. This is a general term, remember. So this is called here derivative of f with respect to here with respect to x, derivative of f with respect to x here, and it is also denoted by, if I take this function, let y equals to fx. If I take function like this, then this is change in y. So f dash x is also sometimes denoted by change in values of variable y to the change in the values of the variable x. This is also sometimes denoted by y1. y1 means derivative of y with respect to x. Or even this is also standard symbol y dash. So y dash y1 dy by dx or f dash x, all are the standard notations for the derivative. Fine. I hope this is clear to you. You just need to keep this definition in your mind. Derivative is one special type of the limit. Which limit? Limit h tends to 0 f of x plus h minus fx. If you observe this carefully, this is nothing but change difference in the values of the function. So we wrote dy because I have considered fx as y, for example. Change in y. What is this x? Which you can rewrite like this, just for information. If I write here, I can write like this, x plus h minus x. So what is this? This is nothing but the change in the values of variable x. So this is by dx. It is denoted by y1 or y dash or f dash x. These are the standard notation. What's the difference between these two? If I put x equals to a, then you will get this definition. This is at a fixed point a, remember. This is in general at any variable point x. Here this definition of derivative function, this definition is also called sometimes is called the first principle. The first principle of derivative. First principle means what? By this definition. There are some other ways also. So by this limit definition, whether it is this or this, it's called the first principle of the derivative. Okay, so now with this we'll see some basic examples about derivative of a function. So let's start with this simple example here. So the first example, the question is here, find derivative of fx equals to x squared. Now here point is not given, that means in general at any point x. Okay, so what we are asked? We are asked to find f dash x. To find f dash x, that's a question. f dash x. So we use the definition, which is called the first principle here. So what is the definition? F dash x equals to, limit h tends to 0 here, limit h tends to 0. You have f of x plus h minus fx, difference of values of the function, upon h. This is the definition. So now this is the question of limit, remember, indirectly. This has nothing to do with differentiation now. Limit you already studied. Once you write this step, now this is a question of limit. Okay, now what's the meaning of f of x plus h? F of x plus h means in the formula of the function here, instead of x, you write what? X plus h. So this is x plus h the whole square. It's not this, remember, it's not x square plus h. This is wrong. In the formula of the function, instead of x, you write x plus h minus what is fx, which is x square upon h. Okay, so this is limit h tends to 0. I think this is clear to you. What I did, I've applied the rule for function. What is the rule for function? In the function, in place of x, you write x plus h the whole square. Now function is no more here, remember, you have used the concept of the function here. Now this is polynomial upon polynomial form, remember. You cannot apply limit directly. Apply, you will realize you will get the 0 by 0 form. So x squared plus 2hx plus h squared minus x squared upon h. So this will get cancelled. Limit h tends to 0. You will find h common from the numerator. So you have 2x plus h upon h. This is polynomial upon polynomial form. So h minus 0 should get cancelled. So now it is cancelled, you see. Now you can apply the limit. So this is 2x. Limit is on h, remember. So plus 0. So you have shown that f dash x equals to 2x. You might be knowing, you might have used even in physics also, what it says, derivative of x squared is 2x. Right? That is, I can write like this if you want. Derivative with respect to x you did, remember. Of which function? X squared. This is y, remember, is 2x. Right? Or you can write like this. All are standard notations. You can use freely any of this. If y equals to fx equals to x squared, then what you have shown, you can write y dash or f dash x, which is equals to 2x. Fine, clear with the symbol? What you have shown, derivative of x squared with respect to x is 2x. It's 2x. So if I take the function as x squared, then you can write y dash or f dash x equals to 2x, or you can call this as y1 also. This is also standard notation. So now we can use this terminology, derivative of x squared with respect to x is 2x, right? Derivative of x squared, this is a function, remember, here this is y. Function is what? X squared. This is just similar to dy by dx notation only, but now value of y is placed. What's the value of y? That's x squared. So derivative of x squared with reference to variable x is 2x. Okay. Now let's see constant function. One more example here. You know constant functions from the type of functions. Fx equals to c, where c is some constant. Type of functions, if you remember. Constant function. Do you remember this? What's a constant function? There, every member of the domain goes to a single number c. This is called constant function. function never change its value. Fx equals to c. C is there on the right hand side. X is not there. Such a function is said to be constant function. Okay. We want here, we find, what's the question? We find f dash x. There's a question. Now, I already mentioned in the beginning, if function is constant, that means there is no change. Every time the value of the function is c only. What is f dash? It's a derivative. What derivative measures, change? If there is no change, then the change should be 0. So here you will see that the derivative will be 0. So f dash x, let's write the definition. Limit h tends to 0, f of x plus h minus fx upon, let's write h. So this is limit h tends to 0. What is f of x plus h? As per definition, for every x, the value of the function is always c. You can choose any x here. This is c. Minus, for any x, this is c upon 0. So this is 0. So limit will be 0. Right? That's what I was trying to tell you. Derivative of constant is 0. Right? Derivative, what this is, derivative of any constant means constant function, is 0. Because what derivative measures? Change. Derivative measures what? Change. If there is no change, that means change is 0. So derivative of any constant is 0. Like this. D by dx of, you put the constant, for example 2. So here fx equals to 2. 0. D by dx. Now here y means let's put 4. So change in 4, 4 never change its value. So derivative is 0. Clear? So derivative of any constant with reference to x will be 0. Fine. So derivative of function a constant function with respect to variable x is 0. Okay, I'll take one more example. Suppose I have fx equals to, let's write x cube. What's the question? We want f dash x. This is the question. Okay, so let's start with f dash x. Limit x tends to 0 here. Sorry, h tends to 0 here. F of x plus h minus, this is fx upon h. This is the definition. This is equals to limit h tends to 0. What is f of x plus h? As we did in the formula of the function, instead of x you write x plus h. So x plus h the whole cube. I repeat, in the formula of the function, in place of x you write x plus h. So x plus h the whole cube minus x cube upon h. Now it's a question of limit. So you simplify. How do we simplify? This is, you expand by a plus b the whole cube. Expansion. Do you remember? It is a cube plus b cube plus 3a square b. Now even binomial theorem also, 3ab square. This is the expansion of what? A plus b the whole cube. Expansion of a plus b the whole cube. So you just use this, take h common, cancel it. You will notice that you will get 3x square. So what I'm trying to tell you is derivative of here, derivative of function fx equals to x cube is 3x square. You know this. Fine.